For Module 5, we continue the conversation of probability. We look at it through the lens of what we call probability, discrete probability functions and expected values. We start with something called a random variable. Now, it's a variable that we've considered in the past with statistics, a quantitative variable specifically, but this time this variable depends upon some random component, right? And this random variable is not like the one you think in algebra, right? Where algebra, the x represents a single value. It's just an unknown value. While for a random variable, it can take on multiple values, right? And there's a probability associated with each of those outcomes. When we think about this random variable, there are two types we will call discrete and continuous. We discuss continuous random variables in the future modules. For these modules 5 and 6, we'll be looking at discrete, right? Examples you can see in the table here. So if you think about, for example, let's say we identify 100 people and we measure how many steps they take to run a mile, right? Each person would have a different amount. Some may have the same amount, but we'll end up with some distribution or probability associated with the number of steps. But again, those values would differ from person to person, hence the variable. And then once we view it through a random or a probability lens, we'll think about it as a random variable. What's the probability that someone takes 1,000 steps to run a mile? 2,000 steps, 1,050, right? Those are the types of things we're thinking about versus you have these continuous ones. An example for a continuous random variable would be the amount of time a person takes to run a mile, right? It's not discrete where it's countable, where we have a certain amount of steps. There's an infinite amount of times if we measured correctly, right? And so that's kind of the difference between what we call continuous and discrete. These discrete ones, we have kind of what we call countable, right? We're able to kind of make a list of the different outcomes versus continuous variables have an infinite amount. Now, when we think about these random variables, what we want to analyze is what we call the distribution, right? What we would call this is the discrete probability distribution table. So it's going to look similar to the distribution tables we've had in previous modules, but again, we're adding the random component. We're viewing the values of this variable from a random perspective and then associating a probability with it. And you want to recall again right here, it's important to recall kind of the definition of a distribution. What are all the possible values and their frequencies? In this case, for a probability distribution, it's the same idea, but we're really going to be looking at the relative frequency or the long run, right, outcomes. How often will they come out? And so here's what we have in that step 1 and 2 here as we think about all the possible outcomes. And again, the frequencies in this case are the probabilities, the long run frequencies.